find myself in the usual position for ops. We're at the end of the line, and it's, you know, hurry up, and why can't you guys move faster than that and get the job done? But anyway, I want to give credit to Tom. He covered the program management and the design and development functions that are so critical. It does start back with the vehicle design and development and test. You have to meet the basic mission requirements with your design, but it has to be robust, it has to be flexible, you have to have the necessary redundancy, and you have to have the crew and flight control capabilities to interact with the vehicle and carry out the mission. Now, in operations, we tend to summarize what it's all about by saying, well, it's about planning, training, and flying. But in order to do that, it requires the facilities, the tools, the training, and flight control personnel who do the planning and in partnership with the crew execute the mission. So that's kind of how I'll go through the steps in operation. The operations organization structure has evolved over the years. It has stayed quite stable through the shuttle program in recent years. But until shuttle, the trajectory design, that all important function carried out by the people who specialize in that field. The flight planning, the training and the mission simulators and the other training, the flight control function and the facilities, if you can believe this, were spread across separate divisions and in 3 different separate directorates at JSC. Obviously, there were too many handovers, too many places for something to drop through the cracks. So over the years, the organizations and their interfaces and their processes were brought together for shuttle. There was a question earlier about what about the downtime in the program? Well, in operations, we used the unfortunate downtime that we had because of some problems in the program. We always went back and examined the processes and the process control and tried to streamline that even further. The consolidated organizations really did enable better planning processes and product streamlining, and contract efficiencies definitely came out of that. That was really the origin of several modifications along the way, but in the dependence on the United Space Alliance organization, who is the prime support arm of operations in Houston. Okay, the operations role in design and development, I said it has to start back at the beginning of the program. Well, the ops community has to be involved in the design, development, and test to assure that the system designs meet the operational requirements. And in order to make sure that we were prepared in our approach to the program, on every program since Skylab, we developed a baseline operations plan. Now, admittedly, some of these operations plans have short life for each one of the revisions. For example, for shuttle, we started out with a baseline operations plan that had us flying 40 flights a year. Training crews was held to a minimum. They were flying so much they didn't have time to do ground training. And you know, it took payload processing to a new maximum. That didn't quite happen. But the baseline operations concept did allow us to figure out our staffing and our training sequences and everything to put those flight controllers that you need with the backgrounds they have to have in the Mission Control Center. One thing that did turn out very positive was the development of system schematics that the flight controllers put together. They took a different approach to the system layout in that they put emphasis on the instrumentation points and the controls that they had from the ground or that the crew had for the system. Well, that approach and the extremely detailed breakdown of the functions and the components within the system turned out to be so valuable that those schematics became a part of the design and risk management evaluation process for the program. And it continues to this day. And every time there is one of those slight modifications to the program, you're back to the drawing board, making sure that that's all reflected in these system schematics. We did participate with the crews in the cockpit layout reviews, and the test prep participation was so important. It allowed us to capture the database for ops support. And I can't tell you how many times we encountered a problem in the mission, but in order to sort it out and find a solution that worked, we had to go back to test data that came out of evaluations in the vacuum chamber or dynamic tests or whatever. That's an extremely important database, and one that we have to make sure that in future programs we continue to capture as you go along. Now, you can sometimes, in your zeal to streamline and keep moving ahead, let the rationale behind some of the changes you've made kind of slip. Well, I'll just mention at this time that the flight controller's Bible is his set of, or her set of mission rules. And we discovered after we were pretty far along in the shuttle program that we had unfortunately lost the rationale that went into some of the original mission rules or the changes made to those mission rules. But we stopped right there, and it was a big workload for the people. But we went back, recreated that rationale, and now if you're submitting a change to the flight rules or important software procedures and all that, you have to have the rationale defined before it's even going to be considered as a change. Okay. Budget problems. Well, it turned out to be a budget problem. The early shuttle mission control center in Houston was a carryover from Apollo, Skylab, and ASTP. And in that setup with its big mainframes and no workstations, mission-to-mission reconfiguration was difficult and costly. Any modification to what you were going to see on the displays, how the data coming from the spacecraft was processed, and even the control of the voice loops was managed out of these big mainframe computers. It was an extremely costly and inefficient process. So we took a proposal forward to, as a matter of fact, it was John Yardley, for MCC modification and modernization. This was fairly early in the program. We could see what we needed. And I'll always remember, that was one of my first direct appearances before Mr. Yardley. And he listened patiently, as he always did, and at the end he said, "Young man," and this was a lot of years ago, you can tell, "Young man, if we don't put every resource we have on the design and development of the hardware, you aren't going to have anything to operate. Go figure out how to get by." Well, we had to get by for a good number of years, and finally, now I'm really dating myself, we developed and put in place the newer Mission Control Center, and that was in '98. We went to a workstation configuration and began phase out of the large mainframes. The last thing to go off the mainframes was the trajectory programs. Okay, flight controllers were then, because of the workstation configuration, given much more involvement in the design of the displays and in the command capabilities. That was interesting how that went. Flight controllers are hardly ever satisfied. And they definitely wanted more control of how the data was displayed and everything. So we put it in their hands. And guess what? When the first displays came into play, they looked just like the gauges, dials, and meters from the old consoles that we had. We hadn't really done anything to take advantage of the software and CRT display capability. So we engaged some cockpit resource management experts that helped us a great deal. The flight controllers then moved very quickly into the picture and have done a great job of handling that. But it was kind of amusing. The new workstation looked just like the old displays. They just used the software to picture the elements. Yes?
What's ASTP for those that aren't
Apollo-Soyuz test program, that's the first time we flew with the Russians. The Cold War was still on. But yes, we flew a mission with Apollo hardware, command and service module, and docked with the Russians. And I think it was an important step in establishing some early contacts and familiarity with certain individuals in the Russian system. And I don't plan to spend any time on that, but, and again, Tommy Holloway can sure discuss that from his involvement with Mir and Space Station. But dealing with the Russians is on a very personal basis. Until they really know you and understand you and trust you, you're going to have a little difficulty doing business. And the same for us in understanding their system. So that was an important step, ASTP. Training and simulators. The shuttle fixed and moving base simulator was located at JSC, and we didn't duplicate the Apollo approach where there was another set here at KSC of the command and service module and the lunar module. The idea was that they do some more of the basic training in Houston and then move to KSC for the last months of training, and the simulators at KSC would really be in flight configuration with the software ropes that were what they called the mission-specific software elements. Well, it was all moved to JSC, has worked out very well. And we also have the cockpit, payload bay mock-ups, and the RMS trainer there. The step that really makes the simulators such an important tool is the simulators were supported as fleet vehicles. When you talk about program control and configuration management, if you're changing the vehicle, there is another set of the necessary hardware, software prepared that goes into the simulator. And as a matter of fact, it goes into the simulator just as soon as it goes into the hardware. And usually it's simultaneously with the shuttle avionics integration lab installation. The workstation system models, we went to workstation-based. Now I'm not talking about the control center workstation-based, I'm talking about computer-based training modules of the systems. And just an interesting thing about the creativity of NASA people. When the Space Center Houston, the big visitor center in Houston, was built, we engaged the Disney Imagineering people to help us design really interesting displays and interactive things that they could use in the Mission Control Center. They were so enthralled with the workstation-based training devices that we had that they incorporated a lot of them directly, hired a couple of the people, unfortunately, and moved out. Really, we really felt good about what our people had accomplished. We also save a lot of time on the full simulators by doing the system training, including anomaly recognition and resolution on these computer workstations. We of course have moving base motion for ascent and landing. That's so realistic, you find yourself grabbing the seat pretty hard if you go over and ride with the crews on one of those. And another big advantage, I drop back to Apollo again, but you know, in Apollo, in order to simulate the approach to the lunar surface, we had to build, or the U.S. Coast and Geodetical Service built models of the moon, and I forget the scale, probably about 1/10 scale. And as they approached the moon, Armstrong, Aldrin, and people following them, what they were really seeing in the simulator was the image produced by a small camera moving across these models mounted in a fixture that could also be rotated and lighted in different ways to give you the impression of the shadowing and everything they might see on the moon. Well, it's common now. All the kids would not be amazed by it at all, but it has been such a boon to the program to be able to really, in the visual out the window view, see the space station as you're coming up on it, do a docking, whatever, in totally realistic situations. And improved simulation supervisors tool. I guess you could, at an extreme, say we gave the sim soups a much wider variety of things to make the crew's lives miserable. They can really create almost any failure situation that could happen with multiple sides to that, so that crews commonly say the training in the simulator is much, much worse than even situations that they've encountered in flight. Okay, preparation for flight operations. We, as I said, have improved planning and procedures, processes, and control data handovers. Nothing in space and in our business is going to be that routine. But we did try to come to more of a process approach with careful attention to configuration control of the process and really careful attention to any quality escapes that should happen, so that you can address them quickly and make sure that they're never going to happen again. Prior to this, we had really gifted people who had spent their NACA and early NASA lives developing the basic capabilities that we used. But before we integrated everything, it was a very fragmented kind of handover. It was done very carefully and it got the job done, but it wasn't a process. It was a group of organizations and people with specific expertise and specific depth of knowledge doing their thing and then handing it over to the next people. You still need those kinds of functions, but it's a lot better if it's happening in a controlled process. And the repetitive notion, of shuttle missions lent itself to more of a process approach. We strengthened the planning and procedures configuration control from Apollo. I spent the last 2 months before the Apollo 11 launch here at KSC working what we call the flight data file, the compilation of checklists and also the flight plan and all that in preparation for that mission. And in the 2 months before launch, we had 1,100 changes to the detailed procedures to be used by Armstrong and Aldrin. They got to the point they hated to see me coming. In fact, they just went the other way sometime. But we knew we had to get control of that and get better review and earlier review of what's the right thing to do, how should we put that in procedures format for the crew, and how do we evaluate it in the simulators and get the kind of feedback we have to have. So a configuration control process was put together for the procedures and flight plan that in the end is as important as the hardware configuration control. So we use that to go to an aircraft type standardization for flight and malfunction procedures and put in increased effort, as I said, on rationale capture. Tom Holloway's been quoted a couple of times. He and I worked together at Apollo, and I remember him saying one time, you can tell what phase of training the crew is in by the changes they're insisting be made in the flight data file. They would start out with all manner of detail and nuances on the detail, and by the time they got down to flight, it was, I don't want to have all that stuff in there, just give me this and this and this, and we'll be ready to go. We really have benefited from the increased fidelity and realism in the simulators. Now the SMS, the Shuttle Mission Simulator, is not a verification facility. That's the sale for the flight software. But the SMS partnered with the sale services many software and operations issues, not major issues. The people doing that work are better than that, but you end up with small issues that the crew sees in training and that you then pursue, and once in a while you have something that you really had better work on. Flight control, I would say that the basics are still the same. The approach to flight control originated by Walt Williams and Chris Kraft and refined further by Gene Kranz and those of us working in mission operations. The real basic approach hasn't changed. It's just that the capability and the technology has changed radically. I've mentioned some of it. The TDRS was one important change. It provides total voice and data coverage. Of course, in Apollo and missions early on, we had just the ground station network, and so you had large gaps in the coverage. And this gave us not only total data coverage, but on the other hand, it did require a stronger bladder control for the flight controllers, because there isn't that gap coming up fairly often between stations. I mean, you're always in contact, so anyway. GPS and the accurate navigation support, fantastic. MCC workstation displays are configurable by the operator. The data presentation reflects that resource management I talked about. And literally, the workstation can be configured to support any flight controller's job. They can sit down at any workstation, take their disks or whatever, and load their tools into that workstation, pick up the data off the net, and go into business right there. We still depend, in case of anything going on that's an anomaly in the mission, on the mission operations integration room. That is the top of the pyramid if you want to get data from the engineering community, the NASA engineering community, or the contractor engineering community. And you can imagine how valuable that is in the case of some mission problems. And I would just like to end by saying, you know, a lot of things have changed. The faces in the Mission Control Center are quite different than when Tommy and I started, but you still have the same dedication and discipline and experience that they've gained through study and work that we had back in Gemini and Apollo, and the supporting organizations still have that same can-do spirit. And now my little commercial, that's the thing about what's going on in the agency right now that worries me. I'm very concerned about what is going to happen to the operations capability for human spaceflight. It takes a long time to develop. People train for years just to move from a backroom position to a front room position, or to a lead flight planner position, or a trajectory development engineer. And if you put that capability aside, it's going to deteriorate, probably won't be covered at all in some cases, and you don't rebuild that overnight. And I really am concerned about the fantastic capability that's been developed and what's going to happen to it in coming months. It's not uncommon for the cost reduction people to very quickly look at operations if you aren't flying a lot. They say, oh, come on, we can cut them way back. So I think it's a concern we have to have and an eye to the future. Thank you.